Let us look at the collision under dynamics. So the collision is occur between two bodies that is in motion when they are in contact with each other within short period of what of time. That is what collision. And the collision can exist in what in two forms. That is, there are two types of what of collision. The first one we have what we call what head-on collision. We have what head-on collision. And the second one we have oblique what collision. So let us look at the words. Let's take it one after the other. The first one is what head-on what head-on collision. Head-on collision is a collision that is occur between what two moving bodies on a straight what on a straight line. For example, the collision that occur between two moving cars is the what is head-on what collision. Like this now, and when we have what a object A and we have another what object like this. Good. So this one is maybe what A, this one is the what B. One A, this one is what B. If the two bodies collide what together like this, you can see that what the two bodies are on a straight line. If they collide together with each other, this kind of what of collision is called what head-on what collision. And the head-on collision, it is now leading to what we call what law of conservation of linear what momentum. Look at this now. Law of what conservation of what of conservation of linear momentum. The law states that the total momentum of a body, total momentum of a colliding body before collision is always equal to the what total momentum of the what of the colliding body afterwards collision. That is, the total linear momentum of the colliding body are what are conserved. That is what momentum before collision is equal to the what momentum afterwards after collision. That's what the law of what of conservation of what of linear momentum, and it can be illustrated as shown in the what diagram what below. If you have a body of A and we have B, the two of them now what collide together. After collision, we have this plus these two after collision. If come what this one is what mass what of this body, let me call it what this body is mass what mass A, mass B, B is what mass A, mass B, abi. And here you can observe that what the on top here we have what? Speed, or mass, let me call it mass M1, U1. Here we have what? U2. This place will be what? V1. We have V2. Let me change this to 1, not AB. M1, M2, M1, M2. So everything you now have here, we call it what? This is what? Before what? Collision. And here we have what? Afterwards, collision. So according to the what? Conservation law, he said what? The total momentum of the body M1, U1 plus what? M2, U2 are equal to the what? M1, V1 plus what? M2, V what? V2. This is what we call what? The conservation law of linear momentum. The momentum of the body before collision is equal to the what? The momentum of the body afterwards, after collision. Now the next thing that we are going to treat now is what? Types of what? Of collision. Or types of what? Of collision. Types of collision. So other types of collision, we have 4 types of collision. The first one we have what we call what? Elastic collision. What? Collision. We have what we call what? Inelastic collision. The third one we have perfect elastic collision. Perfect inelastic collision. Elastic what? Collision. We have super elastic collision. So these are the what? The 4 types of what? Of collision we are going to what? To treat. Now, perfectly inelastic. So yeah, let's take this one after the what? Order. So take what? Elastic collision. So in elastic collision, the both momentum and kinetic energy, both momentum of the body before collision and kinetic energy of the body before collision and after collision are what? Are conserved. That is, in elastic collision, the both momentum and kinetic energy are what? Are conserved. Both of them are what? Are equal. Before and after collision are what? Are equal. That is what? In elastic collision. In elastic collision, the momentum of the body is conserved. The kinetic energy of the body is also what? Conserved. That is, both before and after are what? Are equal. Let us look at what we call elastic collision. As though we have a body. We have a body. We act with this. Another body. After collision, we have this. I will have this. And I forget to add two things to it. In elastic collision, if two bodies collide together, after collision, the two bodies are what? Are separate. They will not stick together afterwards. Collision. You can see it like this. The two bodies they will separate and move with different what? Velocity. So say this is what? M what? M1, M2, M1, M2. And here we have what? V1, V2, V1, V2. So for this body now, we can say that what we have mass of what? Of body M what? M1, U1. This one will be what? M2, U2, which is momentum. And to give us what? M1, V1, M2, V what? V2. If you look at what? Everything you have here, this is the momentum of the what? Of the body before what? Before collision. Everything you have here is of what? After collision. So the total momentum of the body here is equal. Let me use the word equal instead of arrow. It's equal to the what? The total momentum of the body afterwards collision. Likewise, for kinetics what? Energy. For what? Kinetic what? Energy. For this kinetic energy, we can have what? The total momentum. Let me write it here. For kinetic energy, we can have what? Here will be half of what? M1 U1 square plus half of what? M2 U2 square. Everything equal to what? Half of what? M1 V1 U square plus half of what? M2 V2 square. So everything you now have here is also what? Kinetic energy before what? Before collision. This one here we have what? Kinetic energy after what? Collision. So you cannot say what? Say what? Kinetic energy of the body before is equal to the what? Kinetic energy of the body afterwards collision. So and again, for this elastic collision, I will have to what? To note some basic facts here. What is the fact? Note that if mass, if what? Mass M1 is greater than what? Mass M2. If the mass of this body is greater than what? Mass of what? Of M2. The body, the M1 is what? Will maintain its what? Its direction. The M1 will what? M1 will what? Maintain its what? Its The what? Direction. When the mass m1 is greater than what? Mass m2. After collision, the mass m1 will maintain its what? Its direction. And to maintain its what? Its direction, let me put this one here as the direction of velocity. Yes. But in another case, if mass m1 is less than mass what? M2. And that's what? This M2 is what? Is bigger. The mass M1 what? M1 is less than what? Mass what? M what? M2. The observe that what? The mass M1 will what? Will bounce back. M1 will what? Will bounce what? Back. And move in opposite what? Direction. If the mass of what? Of colliding body of what? Of M1 is what? Is less than what? The mass what? M2. The M1 will what? Will bounce what? Will bounce back. But if the mass what? M1 is greater than mass M2, the M1 will maintain its what? Its direction. But the third case is what? If mass M1 is equal to the what? M2. The two body will be at what? At rest after collision. So after collision, the what? If the two body they are what? That at rest, they are not moved. Simply means what? The mass of the what? Of the body are what? Are equal. But after collision, if the mass M1 is what? Is bounced back, simply means what? The M1 is what? Is less than what? The mass M2. But when the mass M1 is greater than what? Mass M2, after collision, the mass M1 will what? Will maintain its what? Its direction. Example of what? Of elastic what? Collision. We have what? Atomic what? Atomic collision. Collision between what? Two or more gas. Atomic what? Collision. And then we have collision between two or more what? Ball. So when two balls are what? Are collide together in the field, is a good example of what? Of elastic what? Elastic collision. When two balls collide together, they will bounce back. So they will not stick together afterwards. After what? Collision. So the next type of collision now is what? Is in what? Inelastic. So if you are talking of what? Of inelastic collision, is a kind of collision in which what? The both which the only momentum is what? Is conserved, but kinetic energy of the body is not what? Conserved. And after the collision, the two colliding body they stick together and move with the same what? Velocity. Once again, in inelastic collision, so the both what? Momentum. The only momentum of the body is what? Is conserved. But kinetic energy of the body is not what? Is not conserved. Loss of energy occur in inelastic collision. But in elastic collision, the both momentum and kinetic energy they conserved, they are equal. But in inelastic collision, the only momentum is conserved, kinetic energy is not sir, that is what the momentum is equal in what in inelastic, but kinetic energy are not equal. There is what loss of energy in what in inelastic collision. So in elastic collision, after collision between the two body are separate from each other and move with different velocity. Like what I said here. But in what elastic collision, after what collision, where two bodies will collide together, after collision, the two bodies will what they will stick together and move with common velocity. And the example of what of elastic collision is the collision between the bullet and human body. So if they release a bullet from the gun into the human body, the bullet will enter the human body, and the mass of the bullet and the mass of the body, they stick together. They will now move with what? With common velocity. So for the in elastic, or the collision between what the bullet and the pendulum bob. So when the bullet hits the pendulum bob, it will penetrate the pendulum bob and the bob will move. So that is what inelastic collision. This is the diagram for the inelastic collision. So if you have this is what mass m1, mass m2, m1, m2. See that this is moving along this direction, u1, u2, both of them move with the same velocity v. So by writing out the equation here, we have m1 u1 plus m2 u2. This is momentum. So give us v into mass m1 plus mass m2. So this is the formula. Let me put it this way. So this is the formula used for for inelastic collision, where everything we have here is before, everything we have here is after. But in terms of kinetic energy, the kinetic energy will be half of m1 u1 plus half of m2 u2 should be equal to the half of m1, no, mass are the same. It will be half of m1 v square m1 plus m2. So the kinetic energy we have before is not equal to the kinetic energy after. So this is what we call kinetic this is before. This one is what? It's after collision. You can now say that what? Kinetic energy before is not equal to the what? Kinetic energy after. Ke before is not equal to what? Ke what? After. So, so we can also say that what? The kinetic energy of the body before collision is greater than kinetic energy after what? Collision. That is what? Loss of energy what? Occur. Loss of what? Of energy. Loss of what? Of energy occur there. So this is what? In what? Inelastic what? Collision. And in this inelastic collision, there are three special cases of inelastic what? Collision. Like we have what? The three cases here. I say what? So for the inelastic collision, and the cases of inelastic collision include what? This case. One. So this case, they are the condition that we apply if you are request to what? To calculate inelastic what? Collision. I will give, yeah, we are going to what? To explain what? Three what? Three cases here. So yes, special case. Let me put it like this. Special what? Case of inelastic collision. Inelastic what? Collision. Special case of what? Of inelastic what? Collision. Inelastic collision. The first one, I said I'll give you three cases here. The first one is what? Case one. Case what? Case one. If, let me put it here. So if two objects of different mass are moving in the same direction with different velocity. The two objects we have here, they are moving in the same what? Direction. This is colliding object after collision. We have what? At what? M1, M2, M1, M2. But they will stick together. So what? If the two bodies stick together after collision and they move with the same what? Velocity, that is what? Inelastic. This is what? This is what? U what? U2. Combine it together, we have what? Mass what? Mass U1 plus mass 2 U2 to give this what? Yes now. is equal to what? V into bracket m1 plus what? m2. From this formula now, let us make it the formula. V is current velocity. You now have what? m1 u1 plus m2 u2 over what? Minus m1 plus m what? m2. This is the what? Formula that is used to find the what? The common velocity for the body that move in what? In the same direction. And the second case is case what? Case 2. Yes, I said for case 2. No, before we move to case 2, let me find the what? The kinetic energy for this case 1. Yes. Oh, for what? For kinetic energy. For what? Kinetic what? Energy. You know that what? Kinetic energy Ke before collision is greater than Ke after what? Collision. Abi? Yes. So that is what? You can now say what? Loss of energy. Loss of what? Of energy will be equal to the what? Kinetic energy before minus kinetic energy what? Kinetic energy after. So this loss of energy, let me call it what? L E will be equal to the what? Kinetic energy before will be half of what? Of mass of this U1 plus half of what? Mass of U2 square minus half of M1 plus M2 V square. This is the formula loss of energy for what? For kinetics what? Kinetics energy. So the second case now is what? Case 2. Case 2 states that what? In case 2, if two objects of different mass are moving in different direction, if what? Two objects of different what? Different mass moving in opposite direction. So you have what? Mass this, yes, equal to what? But note that what? They are moving in different direction. This is M1, M2, M1, M2. If they move in different direction, this one face this direction, this one also face this direction. So U1, U2, like this, they face the same direction like this. So here, they face what? They face each other. So in that case, the sign here will change to what? To minus. So you will now have what? M what? M1, U1 minus M2, U2 equal to the what? V M1 plus what? M2 V. So the velocity here will be what? V will be equal to the what? M1 U1 minus M2 U2 everything over what? M1 plus what? M2. This is what? The common velocity if two bodies are moved in what? In the opposite direction. The last case now, which is case 3, if a moving body, if a what? If a moving body collide with a stationary object, so in this case, we have a moving body. One body will be what? Will be moving, plus the second body, which is what? Stationary, to give you what? The two body after collision. So here we have what? Mass M1, M2, M1, M2. Note that what? This is what? U1. Here, this is what? U2 will be equal to 0, because this body is what? At what? At rest. It's not moving. It's at what? At rest. So you will now have what? M1, U1 plus M2, U2 to give us what? V into the M1 plus M2. This is the V, velocity. So you now have M1, U1. This is at rest, plus is there what? Is 0. V equal to the what? M1 plus what? M2. So you now have what? V should be equal to the what? M1 U1 over what? M1 plus what? M2. This will be the what? Velocity of what? Of the body, two body after what? After collision. The last one now is what? The next one that we are going to treat is what? This case 3 is in perfectly what? Elastic what? Collision. So the next type of collision we are going to treat now is what? Is perfectly in what? Elastic collision. So in a perfectly inelastic collision is a kind of collision in which the kinetic energy of the colliding body after collision is equal to the what? 0. And the body, they stick together after collision and remain at what? At rest. A perfectly elastic collision, once again, is a kind of collision in which the kinetic energy of the body after collision is equal to the what? 0, and the body remain at rest after collision, and they what? They stick what? Together. We know that what? For the inelastic after collision, they will always stick together. For elastics, they will separate. So, but in this normal elastics, after collision, they stick together and they move with what? The same velocity. But in case of what? Of perfectly inelastic, after collision, they stick together and the body be at what? At rest. For perfectly what? Inelastic, they stick together instead of moving with the same velocity. For the inelastic here, there they will what? They will be at what? At rest. An example of perfectly inelastic collision is what? Collision between what? Wall and a what? And a bullet. If bullet is coming like this, if you shoot a wall, the bullet will penetrate the wall, and then stay inside the wall. Inside the wall, the wall is taking what? At rest. Perfectly inelastic. Or if you drop a what? A ball into the what? Into the ground, and the ball is what? Is not bouncing back. is also what? Perfectly what? Inelastic. So the perfectly inelastic, they will stick together and remain at what? At rest after collision. Bullet and war. But if you shoot a what? Release bullet from the gun into a human body, when the bullet get to the human body, the bullet will enter the human body. It will stick with what? With human body, and the body will move with the same velocity. So for the perfectly inelastic, there is a collision that is occur is a collision in which the kinetic energy after collision is what? Is equal to 0, and the body stick together and being at what? At rest, perfectly inelastic. This is what? The sketch for perfectly inelastic. They what? They stick together like this. This is what? Mass what? M1, M2, M1, M2. So here we have what? U what? U1, U2. Their V equal to the what? 0, because it's what? At rest. They are not moving. So we can now have what? Here we can have what? Mass M1, U1 plus M2, U2 to give us what? V equal to the what? M1 plus what? M2. Note that what? The body is what? Is at what? At rest. V equal to the what? 0. So if V is equal to 0 there, what can we have now? We can arrive to what? M1 U1 plus M2 U2, which is equal to what? 0 M1 plus what? M2. So you now have what? M1 U1 plus M2 U2 equal to 0. Therefore, we now have what? M1 U1 equal to the what? Minus M2 U2. This is what? The momentum expression for what? Perfectly inelastic what? Collision. And the next thing that we are going to treat now is what? Or the last one under what? We call it what? Super elastic collision. Super what? Super elastic what? What? Collision. So in super elastic collision is a kind of collision in which the kinetic energy after collision is far greater than kinetic energy before what? Before collision. That is, here, the what? The kinetic energy after what? Collision is far greater than what? Kinetic energy of the body before what? Collision. When kinetic energy of the body is kinetic energy of body after collision is greater than kinetic energy of the body before collision, we call it what? Perfectly what? Super elastic collision. But when kinetic energy K what? Ke after collision is equal to 0, that one is what? Perfectly inelastic collision. But when the kinetic energy after collision is greater than what? Before collision, is super elastic what? Collision. But when kinetic energy Ke before is equal to the what? Ke after we call it what? Elastic collision. But when kinetic energy P be what? Before is greater than kinetic energy of what? After is called inelastic what? Collision. So in super elastic collision, the kinetic energy of the body after collision is far, far greater than what? Kinetic energy before collision. Example of this super elastic collision, we have explosion of bomb. The explosion of what? Of atomic bomb is a good example of what? Super elastic collision. The collision between human body and what? And the bullet is what? Perfectly inelastic collision. So between what? Simple pendulum and bullet, this one, sorry, wall and bullet, perfectly. Human body and bullet, inelastic, or pendulum bob and bullet, inelastic collision. Collision between what? The two moving car is what? Elastic. Collision between what? Two ball, call it what? What? Elastic. And then we now have what? Yes, again, we can now divide this collision and what? Let me say colli what? No, before that, before that, let us use what? Coefficient of what? Of restitution. Yes, that's the next one. What? Coefficient of restitution, which is denoted by what? By A. The ratio of relative what? Velocity of separation after collision to the relative velocity of what? Of approach before what? Collision. The coefficient of what? Of restitution is what? E. E is the ratio of what? Relative what? Velocity of ratio of relative velocity of separation after collision to the what? Ratio to the relative what? Velocity of approach before what? Collision. So the coefficient of restitution is what? V2 minus V1 over U2 minus what? U1. This is the formula for what? Coefficient of what? Restitution. And the coefficient of restitution, E is 0 is less than coefficient of restitution. Coefficient of restitution is what? Is less than 1. This is the formula for coefficient of what? Of restitution. And this coefficient of restitution is a quantity that you can use to what? To determine the kind of what? Of collision that is occur. Summary of everything. So we can have it in this form. Number one, we have what? Collision after collision. What next again? We have coefficient of restitution. We have kinetic what? Energy. So here we have what? Collision Number one, we have elastic. Number two, we have inelastic. Number three, what do we have? Perfectly elastic. What? Elastic. Sorry. Perfectly inelastic. What? Elastic. The third one, we have what? Super elastic collision. So these are the types of collision we have. So here, we have put what? Coefficient of what? Resistution. Here we have what? Kinetic what? Energy. So when kinetic energy of before collision is equal to kinetic energy of after collision, the kind of collision is called what? It's called the kind of collision is called elastic what? Collision. And the coefficient of the resistution here is equal to what? 1. But when kinetic energy of before is greater than of what? Before is greater than kinetic energy of what? Of after is what? Inelastic what? Collision. When kinetic energy of before equal to the after, elastic, before greater than after is this, and coefficient of resistution is what? Is less than 1. But when kinetic what? Energy after collision is equal to 0, and here coefficient of resistution is also equal to 0. But when kinetic energy of what? Before is less than kinetic energy of what? Of after, simply means what? Coefficient of resistution is greater than what? 1. Or this one, we can also say what? When kinetic energy after greater than what? Before. So this is the summary of how we can use coefficient of resistution to define collision theory, to determine type of collision, and kinetic energy to determine what type of collision. So let us solve like 2 or more questions on how to use what? Collision theory, or how to use all these formula. Let's solve these 4 questions under type of collision. Question number 1. You are given 2 mass of 2 kg. That is, mass A is what? 2 kg, and B, mass B, also what? 2 kg. Collide the velocity before collision are u1, u2, and v1 after collision. Calculate the final velocity. So what is what? u1. We are given u1 should be 50i plus 30j, and u2 should be minus 10j plus 5j. We have what? v1 should be what? Minus 5i plus 20j. This is it here. And v2 is what? Unknown. calculate the final velocity P2. So here now, we will now use what? Using law of conservation of linear momentum. We say that what? Where M1 U1 plus what? M2 U2 equal to the what? M1 U1 plus M2 V2. This question is come from elastic collision because they are not stitched together after collision. Where what is mass? My mass is 2. U1 15I plus 30J plus 30 what? J plus 2 into the V minus 10J plus 5J equal to what? What is M? 2. What is V? Minus I plus 20J plus M2. M2 is what? Yes, M2 is 2. 2V2. Good. 2 times this, we have 30I plus 60J minus 20I plus 10J equal to what? Minus 10I plus 40J plus 2V2. Yes. This, we have 10I plus 70J. If this one come here, minus 10I minus 40J equal to the what? 2V2. Gallant. This will come plus. We have 20I plus 30J, we have 2V2. So we now have V2 should be what? 20I over 2 plus 30J over 2, everything in meter per second square. V2 will be what? 10I plus 15J, everything in meter per seconds. Good. Yeah, let's solve the second question. A bullet of mass 2 kg is fired into a get embedded in a stationary block of wood 10. If the bullet and the wood are moved freely, the velocity of this determine the initial velocity of the what? Of the bullet. Good. So look at that question. They said a bullet. Let me draw the bullet. Assume this is what? Bullet. This is the bullet. What is the mass of the bullet? 2 kg. Of mass what? 2 kg. We call it what? Do what? Bullet. And it is moving along like this. And the velocity is U1. Yes, which is what? Or what? Unknown. Good. And they said is what? Bullet is embedded on the what? On the block. Abi, assume that what? This is what? The block. The stationary what? Block. Assume this is what? The block. Let me say what? This is what? Block. Stationary block. Of mass what? What is the mass of the block? The mass of the block is 100. So, mass of the block is what? Is 100 kg. But the block is what? Is at rest. So when this thing is what? Is coming in into the what? I'm not satisfied with this diagram. example, this is what? This is block. So block is what? This is block of 100 what? Kg. 100 or 10? It's 10, sorry. 10 kg. So when this is collide with this one now, after collision, the two of them are together. We have the block. This is the block afterwards. Collision. Inside the what? Inside the block. And the bullet is what? Is 2 kg. We have 2 kg for the bullet. And the mass of this is what? Is 10 kg. But they said what? If the bullet and wood are moved freely, velocity of this, that is when the bullet enter the what? The block. So what happened? They will move what? Freely. So they move freely like this with speed of 100 meter per second. The speed is 100 meter per what? Per second. Have you? You are now asked to what? Determine the initial velocity of the what? Of this. So don't forget that what? This block is stationary. When block is stationary, our U2 is equal to the what? 0 under the case. So you now have what? Now what are we using? Mass M1 U1 plus what? M2 U2 should be equal to the what? They have common velocity mass M1 plus what? M2. But since what is our what? M1 is 2. The speed unknown U1. Here we have M2. M2 is what? Is 10 kg. What is what? U is 0. What is the speed here? 100. Mass, it is 2 mass. 2 plus what? Plus 10. You now have what? U1. Yeah, this and this to give us what? 0 equal to the what? 100 into what? Into 12. 12 times 100 is 1,002 what? 200. So you now have what? 2U1 equal to the what? 1,200. So U1, it will now be what? Divide 1,200 by what? By 2. You have 1,200 over what? Over 2. So the U1 is what? 600 meter per second. The speed of the what? Of the bullet is 600 meter per what? Per second. So look at what this question what? Number 3. Number 3 is very simple. It's almost the same thing with what? The first one that I did, but I will solve the what? The fourth question, which is number 4. It's absolutely different from the first 3. Number 4 question. It said a mass A of 1 kg moving to the right with the speed of 6 meter per what? Per second. Look at it. I would like to draw it out. It's moving like this. Of mass what? What is the mass? 1 what? 1 kg. And it's moving to the right like this. What is the speed of moving? 6. Speed is what? 6 meter per what? Per second. Collide head-on with a mass B of 1 point what? This. Collide with what? Another what? Body of mass what? Mass B. This mass B of 4 point what? 1.4 kg. So we have 1 point what? 1.4 kg moving in opposite direction with speed of this. So this one is moving like this. Speed of what? 5 meter per second, 5 meter per second. Yes. After the collision, A is moving to the left with a speed of 5 meter per this. After this collision, the A is moving to the what? To the right. Is moving to the what? To the left with a speed of this. Abi? Eh? Moving in the opposite direction of this. After collision, A is moving to the left with a speed of 5 meters per second. Find the velocity of B after collision. So A is moving what? Like what? Like this with what? 5 meter what? Per second. So if they move like this now, the sign here is minus. Abi? And this here is what? Is still 1 kg. So when this is moving like this now, this is also what? Minus 2. But plus what? Velocity for the second one, which is the body, is this. And it's 1.4 kg. You are now asked to find the what? Velocity of this body, which is what? V2 or what? Unknown. Apply your formula. You will use what? M1 U1 minus M2 U2 is equal to the what? What do we have here? Can use M1 M1 V1 minus M2 V2. Yes. Or plus. Don't worry. Plus. What is M1? 6 times 1. Let me say 6 times 1 minus 1.4 times 5 equal to what? M1 1 times 5 plus what do we have here? 1.4 V2. So 6. We have what? 6 here. Wow. There is a mistake here. Oh, by apply this now. Since there's this 6, here we have what? Minus 7. Here, this one too is minus 5 now. It's a mistake. Minus 5. So we now have what? Minus 5 plus 4 points B square. By collect the items, what do we have here? It's we have minus 1 plus 5 go to the 1.4 V square. Here we have 4 equal to what? 1.4. Hope I'm right. 7 and this is 1 5 square. So you now have what? 1.4. What you have? V2 should be 4 over 1.4. It will give us what? 2.9 meter per second. Therefore, the velocity 2 is 2.9 meter per second. You have to find the what? Find the velocity of B after collision and the coefficient of resistution. So, and as we all know that what? The coefficient of resistution E is equal to the what? V2 minus what? U1 over U2 minus what? U1. So E is the what? What is the V2? V2 given is what? Is 2.9 minus what is what? U what? What is V1? The V1 given here is minus 5. is minus 5 over what? What is U2? U2 is what? Is us. Yes now. 6 square to get the block of this. Let's read of this collide with anyone in the body is in opposite direction of 5 meter. So you have what? 6 minus what? Minus 5. So it will now give us what? E should be what? 2.9 plus 5 over what? 6 plus 5. It will be E equal to the what? 7.9. Add this together. We have 11. 0.718. You know what? 0.718. When the coordinate of resistution is less than 1, what kind of what? Of collision is this? So that's all about what? Type of collision, and that's all about what type of what? Of collision. So we are going to rub the board, move to the next aspect of what? Of dynamics.